Express has been around for more than a decade, which in web development time is practically prehistoric. The fact that it's still the default choice for building Node backends tells you a lot about just how well it was designed. At its core, Express is minimalist. It doesn't force a specific architecture, it doesn't ship with a database layer, and it doesn't try to tell you how your folder should look like. It gives you three essentials: routing, middleware, and request and response handling. Everything else, your choice. You assemble only what you need. This minimalism is a huge advantage. You aren't dragging around features you never use. You aren't fighting an opinionated structure. You build what you want, how you want it. And despite being simple on the surface, Express is a serious production-ready tool. Major companies rely on it. IBM uses Express in their cloud services. Uber uses it for parts of their infrastructure. PayPal migrated from Java to Node with Express and saw dramatic gains in speed and developer productivity. Even companies like Netflix and Trello still rely on Express-based systems. Startups love it, and enterprises trust it. But that doesn't mean Express is the right choice for every project. Express shines when you need a fast, flexible, and no-nonsense backend with REST APIs, microservices, and mobile backends. It gives you complete control without pushing a rigid design. Middleware lets you extend behavior cleanly. Beginners pick it up quickly, and experts can scale it confidently. But you want to skip Express when you want built-in structure and architectural patterns. If that's what you want, go for Nest.js. If you want a full-stack, front-end-driven workflow, go for Next.js instead. And if you need extreme performance and very low overhead, go for Fastify. But for the majority of API-driven projects, Express is the practical, stable answer. And Express is all about building APIs. But what is an API really? The word gets thrown around constantly, but most explanations are either too abstract or too vague. An API is simply a structured way for one piece of software to talk to another piece of software. When you make an API request, you send a URL explaining what you want, a method, which action to perform, with optional data, like a new user to create, and optional headers, like the metadata about the request. So an example request might look something like this. You make a post request to add a new comment with a text of great video and the following user ID. And then the API responds with a status code, a JSON body, and some optional headers that looks like this: 201 created, text great video, created ad, and an ID. Clear, structured, and consistent. And if you want to go much deeper into APIs with diagrams, real-world examples, and plenty of hands-on practice, I break everything down in much more detail if you haven't already. But now, let's build an API. Back within our code, cd out of 01 Node.js and cd into 02 Express.js. Then open up that folder, and the first thing we want to do is initialize a new package JSON by running npm init-y. As you can see, this will have generated a package JSON file. Now, to make this an Express application, go ahead and run npm install Express. Then you'll see within your package JSON that there is one dependency called Express, and under scripts, we can remove this test script and instead add a dev script, which will start the developer server by running node --watch server.js. This will keep track of all of the changes within a server. So let's create the server, which is going to be very similar to what we had in our original application. So I'll go ahead and copy this entire part and simply paste it into a new server.js file that I'll create within the Express.js folder. This time, it'll be even easier. Instead of importing HTTP, we will simply import Express coming from Express. Then, to create a new Express application, you can just type const app is equal to Express. And this will create a new instance of the Express application, giving you an app object that we'll use to define routes, add middleware, and configure our server. Typically, you also want to define a port right here. So we'll say port is set to 3000. Then, instead of writing this server, HTTP create server, and then server.listen, we'll do it in a bit of a simpler way by saying app.get, and we'll listen on /route, which is the root route. And then as the second parameter, you can define the request and the response objects. And then you can open up the function block where you can define what this specific route does. So what we've created right here is a route. So you can say res.send hello from the, and we're now building a specific API. For this demo, we can maybe build a cars API. So hello from the cars API. We'll be returning some car data. And then to actually be able to call this root route, we need to run app.listen on a specific port. And once we start the server, we can also run a console log. Server is running on, and now we can say HTTP ://localhost, and then it's not hard-coded anymore. So instead, we can render a dynamic variable of port. But for that, you have to wrap this in a template string. Now, if you open up your terminal, I'll do it right here so we can see both the code, and run npm run dev. You'll immediately get an error saying that you cannot use an import statement outside of a module. That's because Node.js applications still use older require syntax. To be able to use modern ES6+ imports within your package.json, you have to change the type of the application to module. If you change that and rerun your application by stopping it from running by pressing Ctrl+C and then running npm run dev, you'll see that now the server is running on localhost 3000. If you open it up, you'll see hello from the cars API. Perfect. This is a functioning API with the one API route. But that isn't all that interesting, is it? We have to add more routes that'll determine how our API behaves for different URLs and HTTP methods. So you can add another route, something like app.get /API /v1 /cars with a request and a response objects that'll simply res.send all cars. So imagine here we have a database, and we'll talk about that soon. But if we had it, when a user makes a request to this API route, you will return all the cars from the database. Then right below it, I'll do app.post. So we're changing the HTTP verb from get, retrieving something, to post, which is the endpoint to create something. I'll again make it the same, API v1 cars. Yep, you can have multiple endpoints as long as they're different verbs, request and response. And here I'll do a res.send new car. We have created a new car. See, a post request always implies that the client is sending new data to the server, typically in a JSON format, and expects the server to create something based on that data. Even though this example only returns a text message, this is the endpoint where you would normally extract fields from the request.body, validate them, and then insert a new car into your database. After the get and the post, we have the third one, which is the put route. So app.put, again, API v1 cars, but this time you want to add a :/ID at the end of the route. This :ID segment in the path is a dynamic parameter, which means that Express will replace it whatever value appears in the URL and then expose it through rec.params.id. So for example, if somebody calls your API with the following text, so it's going to be API v1 cars 5123, then this variable will have 5123 value inserted into it. This is called a dynamic route. This is typically used when you want to update the information for a specific resource, in this case, a car. So I'll say res.send update a car. After that, we can do another one to delete a car. So similar to what we've done before, we want to get a specific ID so we know which car we're deleting. And then you simply want to use the app.delete route. Again, typically within here, we would enter our database, find the car, and then delete it. But here right now, we're just sending a message saying that we are about to delete it. And finally, there's one more type of a common route, which is app.get, which we've had so far, but this time it's cars and then an ID. Not just cars, where we're getting all the cars, but here you want to get the details of a specific car. So this is how a typical, very simple API would look like. But notice the repetition. The API v1 has been repeated everywhere. So if you were to update your API to v2 and then forget to change it in a couple of places, that would just be a mess. So thankfully, Express gives you a cleaner way. They're called group routers. So you can say const router is equal to express.router. Then you can define that router right here at the bottom by saying app.use. So we're using a specific router, and it'll start with API v1, and we'll feed the router that we just created. This means that every single route with this router will start with API v1. So what we can do now, instead of repeating ourselves every single time, we can just simply remove this, only have the needed parts, which is the either / or the colon ID, but then instead of using the regular app, we're now gonna start this with router. Router.get, router.post, put, and so on. Hopefully this makes sense. No need to repeat ourselves because it already knows that all of these routes start with this prefix. But now let's add some real car data. Right here at the top, I'll say let cars is equal to an array where we can have a couple of objects with an ID like 1, a make of the car, like let's do a Toyota. We can do a model like a Camry, and maybe a year, 2022. And we can also add a price. Let's say that it's 28,000, let's say it's USD. And you can duplicate this a couple of times, change the IDs, the makes. In this case, let's say we have a Tesla Model S, year 2023, with a price of 25. And then finally, we have a Ford, let's say model F-150, and with a year of 2021 and a price of 35. So what you've created right here is a sort of a database. Not really, right? It's just an array, but what's missing to make it into a database is data persistence. We'll talk about that very soon. Now, to be able to retrieve those cards through our API, we have to tell Express to parse JSON from incoming request bodies. We can do that by typing app.use express.json. Without this, when someone sends JSON data to your API, you wouldn't be able to read it. This is one of those essential middleware functions you'll use in almost every single Express app. So now we can replace this getAllCars route by simply saying res.json cars. And then we can also make it /cars, right? Then we're going to return all the cars. You can give it a shot by opening up the app in the browser and heading over to localhost 3000 API v1 cars. Now you'll see that I have an extension opened that renders all of that JSON in a nice format. You can find a simple Chrome extension, something like JSON Viewer, and that should work on your end too. But otherwise, it's going to look something like this. It is just an array of different objects. Perfect. Now what you could do is also implement all of the other functionalities. For example, getting a car by ID. I'll take this code right here and put it in the second place right after getAllCars. And think a bit about it. How would you get a car with a specific ID? Well, first, you would have to know that we can get the ID from rec.params.id, as I explained before. You would also have to know that everything that we get through the params is in a string format by default, which means that we have to convert it into a number if we want to do some comparisons with it. Then we want to find a car that we're looking for by running cars.find. We want to find a specific car where its ID matches the ID that our user is searching for. If there is no car, then we can return some kind of a res.status of 404 and the message of car not found. Else, if we can find the car, we can simply return it by saying res.json car. Now, back within our application, if you search for localhost 3000 API v1 cars and then / maybe 5, you'll see car not found. But if you change that to 1, 2, or 3, you'll be able to see that we directly get back the data. Now, you wouldn't show it to your user like this. You would most likely show a nicely designed car marketplace page where you're going to show that car's price, some photos, title, and more. And now you could go ahead and implement all of these other functions to make this simple API actually functional. I'll leave this as a challenge to you. Try to figure out how you can append a new car to the cars array, how you can update a car, and how you can delete a car. All of it has to do with modifying this array. Pause this video and give it a shot right now. I'll continue with the solution in 3, 2, 1. Okay, how would we implement this post route? It would look something like this. We make a post request to / cars, and then the user that's making this API request will have to pass all the important information needed to create it. In our case, that is the make, model, year, and the price. All of it, which we'll get access to through the request.body. You might be wondering, how is somebody going to pass these pieces of data? So far, we've only seen how GET requests work. You simply change something in the URL and that's it. That's because by default, when you make a request in your browser, it makes a GET request. But to make a POST request, you'll need some kind of an HTTP client tool. It can be Postman, Insomnia, or in this case, I'm using HTTPy. Here, you would type 3000, right, for localhost 3000, API v1 cars, just to verify that our API is working, and we can see that it is. But now, here we have the options to also make all sorts of different requests, like a post request, where we can pass the additional body into it. In this case, we're passing JSON, and as we know, we have to pass a make, a model, a year, and a price. Perfect. It'll look something like this, but we have to think of another one. So let's go with something like a BMW. Maybe we can do a 4 series, year 2020, with a price of about 15. Now, when you click send, this HTTP client will have made an HTTP post request to our server, and you'll see that we got a 201 created, which means that it got added to our array. So now if you again make a GET request, you'll be able to see it right here. The way it works is we extracted all of those values that we passed through the request.body. We checked if some were missing. If that is the case, we threw an error. But if none were missing, we created a new car object by increasing its ID to be the new one in the list. We specified all of its variables, and then we pushed it to a car array and returned the newly created car. Pretty cool, right? Situation is pretty similar for the updates too. So if you wanted to update a car, that would look something like this. You would first figure out which car you want to update. You would then find the index of the car you want to update in the database. If it doesn't exist, you would return a 404, car doesn't exist. Else, you check whether you have provided all the fields needed to update it. If they exist, then you make the modifications to the car in the database, and then you simply return the updated car. And finally, there is a delete a car request, which is even simpler. You again have to get the ID of the car you want to delete. Then you want to find the car. If the car doesn't exist, you return a 404. If it does exist, you simply remove it from the array. And with that, you've implemented a very simple API with a non-persistent database. One part that is missing right here is some kind of logging, because as your API grows, you'll want to run certain code for every request, such as logging, authentication, caching, rate limiting, or performance tracking. Doing this inside of every single route would just be a mess. So instead, middleware solves this. Middleware allows a specific portion of your code to be called before or after any single request that a user makes. So right here on top, let's add a middleware. You can do it by running app.use. You get a request, a response, and the next object. This next object is what makes middleware, well, middleware, because middleware has to know when it's ready to move the action to the next API call in line. That's what we use this next object for. So, for example, let's create a middleware that simply logs out the timestamp of when a specific request is made. So const timestamp is equal to new date, and we want to get access to the ISO string. So dot to ISO string, and we want to console log it in this format by first rendering array signs, timestamp, and then we want to also render the rec.url as well as the rec method so that we know what the user is doing. Now, every time somebody makes a request to your server, you'll be able to see it in your terminal thanks to this middleware function. Let me show you. I'll open it up, and immediately, as soon as we load localhost 3000, you can see that somebody made a GET request to the root route. But there is one problem. You can see that we never provided the next functionality to this middleware, which means that it intercepted our try to get to the root route and stop there. It simply logged its thing, and that's it. What you want to do instead is whenever your middleware finishes doing what it's supposed to do, in this case, log the timestamp, the method, and the URL, we can simply call the next method and allow it to continue going where it needs to go. So now, back in the browser, we get a notification that we made a request, but then immediately we can see the page we're supposed to go to. So if we go to API v1 cars, you can see that we made a request to API v1 cars at this specific time. Middleware functions can be used for all sorts of different things, like logging, what we've done right here, security, compression of files and images, validation, authentication, error handling, performance metrics, and more. It is the backbone of all Express applications. Now, features like rate limiting, bot detection, or user abuse prevention are all things that developers attempt to build manually and then quickly regret it. That's why throughout this course, I'll show you how to use RJet properly so you don't just build, but build in a way that's safe, scalable, and production-ready APIs. Basically, RJet provides these protections with clean middleware APIs. Since we'll be using it both on the front end and back end, go ahead and create your free account right now. The link is down in the description. You can click sign up for free, sign in using GitHub, and you got your site key, which we'll use later on to secure our application. So in this one single lesson, you've built a complete REST API. And not only you've built it, but along the way, you've learned what Express is and why it remains the industry standard. You learned when to use Express and when to choose some alternatives, how routing, parameters, methods, and status codes work, how to structure routes cleanly with routers, how to build CRUD operations, how to parse JSON bodies, how to add middleware for shared logic, and how real APIs are shaped in production. But there's one huge flaw in the API we built, and that is that your data disappears every time your server restarts. So if you go ahead and add some cars, then restart your server, and then try to get them, they're not gonna be there. That's happening because you stored everything inside of an array. Arrays live in memory. When the process dies, they die with it. So how do you store data permanently on a server? For that, you need a database. And that's where the next piece of the PERN stack comes in.